This is Pearson 3-8 with perpendicular and parallel lines. Our learning target is I will compare slopes to determine and develop parallel and perpendicular lines. Let's talk about what it means to be parallel. What it means to be parallel. We have learned that parallel lines can be represented graphically using two central arrow markers. If I call that line A and line B, that means that line A is parallel to B. We can also say that the slope of line A equals the slope of line B. Now that's the more algebraic version that we need to know. That's what this lesson is all about. So let's do an example of how this stuff works. I'm going to give you two sets of coordinates. -3 and 3, -1, -4. The other set is -1, 5, and 2, -4. I'm going to do the first set using a more traditional approach, which you learned in Algebra 1, and then I'm going to use the second set with a more conceptual approach. So we should know that slope is change in y over change in x. Or if you expand it, y2 minus y1 over x2 minus x1. So if we go in, let's make sure we label these to make sure you guys understand. This will be x2 and y2. So we can say that slope is -4 minus 3 and -1 minus -3. Please notice the use of parentheses. Anytime you substitute a negative, you need to use parentheses. If we keep going, we get -7 over +2. All right. Now, that is one way to do it. The other way is a more conceptual approach, which I prefer, but tomatoes, do what is best for you. I draw arrows. I understand this is a literal change in x and a literal change in y. So I think, how does it go from -1 to 2? Well, it has to add 3 on a number line. How does it go from 5 to -4? It has to take away 9 on a number line. So that gives you slope. Slope is -9 over 3, or reduced -3. Now notice these slopes are not the same. So we could simply say, we'll go back and label these for the sake of this purpose, that the slope of line 1 does not equal the slope of line 2. So the lines are not parallel. Let's look at another example. This is the one you're going to try. The coordinates are -6, 1, 0, -2, 0, 3, and 4, 1. Take a moment to solve this as my previous example. Alright, so this is what you should have gotten. Do the same thing I did in the first one. I'll do one each way. So slope is -2 minus 1 over 0 minus a -6. So that should get you -3 over 6, or -1/2. Let's do the same thing with the other set. We'll do a more conceptual approach. The change in x is a +4, and a -2 for the change in y. So slope is -2 over 4, or when you reduce it, -1/2. Please note these are the same. So you could say that the slope of line 1 equals slope of line 2 So the lines are in fact parallel.